All right, good morning. Welcome. This is an early start for all of you, for everyone, I'm sure. My name is Damian Thong. I'm the head of Japan Equity Research, also one of the senior technology analysts covering Japanese as well as Asian equities. Myself covering the Japanese equities for now, basically about 2 decades. Now, this morning, I am very pleased to introduce to you Dr. Sakya Dasgupta, CEO, founder of EdgeCortix, one of Japan, I would also say Asia's most innovative AI companies, specialized in particular in bringing AI to where it doesn't really exist today, which is at the edge, inside devices that are close to you. A lot of focus today on AI, obviously the cloud, but I think as AI proliferates to more devices, really brings, I think, AI into a place where Sakya is trying to address. So without further ado, I would like to introduce Dr. Dasgupta Sakya onto the stage, and over to you.
I don't know which mic I'm speaking into. This one is working? Okay, excellent. Good morning, everyone, and thanks, Damian, for the kind words. It's a pleasure to be here speaking to all of you. I believe it's already been quite an eclectic session yesterday. I went through the agenda. Unfortunately, I was not there in the session, but it did look like a very eclectic mix of different topics from AI and quantum. At EdgeCortix, we are really focused on building systems from software all the way to hardware, silicon, semiconductors that can enable us to create a lot more energy efficient, greener, sustainable solutions. And before I kind of get into what I'll talk a little bit about the challenges that we face in that endeavor and at least give you a glimpse as to how we have been solving those challenges, and hopefully we'll get into more of an interactive chat. That's what I'm really looking forward to. But just to give you a little bit of background, I myself, it says doctor somewhere there, so I'm always nervous whenever it says doctor. So just to know, so that you know, my PhD is in the area called neuromorphics, and that's an area which looks at the brain. So today we are still very far away from that aspect. So the semiconductors and devices that we are creating is a lot less efficient compared to this thing that we are all carrying with us, around 15 watts of power consumption, but it computes almost everything. That's really the endeavor as the industry, that we want to get towards devices that are a lot more energy efficient, similar to what the brains can do. So before I get into that, let me just walk you through a few aspects of who we are as a company. So at EdgeCortix, our core mission as a company, we are still a fairly young company. We were just founded in 2019. But we've been growing quite actively based out of Japan, where we are headquartered, but we also have presence in Singapore, in US, and very recently we started a new center in the beginning of this year in India, in Hyderabad, where we are all seeing a lot of talent pool at the intersection of software and semiconductors. Our corporate mission is really to focus on an area of the market which we colloquially call edge or edge computing. Essentially, think about any device. Classic example would be a smartphone constrained by size, weight, area, power. How do we bring AI computation, all the goodness of language models, generative AI that we are now talking about? And when people think of AI, they think of data centers. So we are focused on the other side of the continuum. How do you bring all of this goodness to constrained devices without sacrificing performance, while enhancing the efficiency? Make it a lot more power efficient and cost effective for enterprise customers. And we do that by creating a platform. I'll give you a glimpse of that. I won't go into the details, but a platform that goes all the way from software to silicon. Gone are the days when companies were creating, in my opinion, purely hardware-centric solutions, let's say semiconductor-first solutions. Those days are gone. Classic example would be the biggest GPU company that all of us admire. They have taken a very much a software-centric approach to the industry. And we take a leaf out of that book as well. So even when we're looking at EdgeCortix as a company in the edge space, we've been focusing on creating software-first ecosystem and an integrated platform that can go from software all the way to silicon solutions. And in that, we are backed by investors, just a few prominent ones that I just wanted to highlight. SBI in Japan, Renaissance Electronic Semiconductors, they have been a strategic collaborator and partner for us for several years now. and we work very closely together. I just highlighted a few of those aspects today. So if you think of microcontrollers, microprocessors from Renesas, we are part of that ecosystem very actively. So you're probably playing with our solutions if you're interacting with any of Renesas's microcontrollers and microprocessors today. But that relationship goes even further. So you'll see a lot more goodness coming out in the future, where you'll see our interaction being shared more prominently publicly as well, where our hardware devices can enhance capabilities for Renesas and vice versa. So with that background, let me jump into really what I'm here to talk about, AI and semiconductors, and how we are kind of trying to innovate across that space. So if you look at this imagery, it really kind of talks about the huge impact that the industry has had in the last couple of years, really. I've spent the last better part of the 2 decades in the AI industry, even before deep learning that we today use existed the way we know it. So we were doing machine learning traditionally. But in the last 2 years, it's become very colloquial. Everybody is talking about generative AI, or language models, ChatGPT, models like Llama, if you've heard of that. The key idea is that all of those goodness, the power that comes from these kind of models, has also created this demand to enhance the way we design semiconductors itself. So if you're now creating semiconductors for that AI market, you need to rethink the way we do it, and you also need to rethink not just the way you build semiconductors, but what you're focusing on. Is it general purpose, or is it really AI focused? And in that endeavor, there are a few challenges. I'll try to walk you through some of those challenges. It'll be a tall order trying to answer all of those questions, but then I'll try to kind of summarize by how at least we have been tackling some of those aspects, and then we'll go into hopefully a conversation where we can uncover more aspects of that. Before I do that, hopefully many of you are familiar with this. There's a lot of information out here, but there are only 2 things that you need to focus on. The first is this green curve. So hopefully everybody in this room, if you've heard of semiconductors, you should have heard of Moore's law. So Moore, of course, very famously created this, what we call law. It's really an expectation that has existed in the industry for several decades now, which talked about the fact that every year you would have doubling of transistor density. In layman terms, it means that in any given unit area, every 2 years you can fit twice the amount of transistors. And that wave, that expectation has become true, and that's the reason we call it a law. Unfortunately, Moore's law in that traditional sense of transistor density doubling every 2 years has ended. That's a fact. And it has ended several years ago. But there is still an optimistic view in the industry. That's shown here by the yellow curve and the projection that you see in terms of the orange curve there. Let's see if the pointer works here. Okay, maybe a little bit of lag. And that orange curve talks about how do we create system-level innovations today that allows us to still keep Moore's law alive, but in a very different format. For example, transistor density doubling does not exist anymore. As a result, purely concentrating on multi-core processing that the industry was focusing on 10 years ago does not give you a lot of value anymore. At some point, you'll hit the wall with 2 nanometer, 1.8 nanometer, maybe at 1 nanometer, then you're getting into atomic effects, quantum effects. So how do you actually break across that barrier is through what we call system scaling. That, in layman terms, means can we innovate across the space of packaging, across the substrate, across the way we form semiconductors together. Rather than creating a single die, a monolithic system, can we integrate multiple dies together? In the industry, we call it chiplets or system in packages. So rather than doing system on chip, SoC, that really means that you bring together complex pieces of IP, intellectual property, into a single die. And that has existed in the industry for a long time. Instead of that, we are now focusing on breaking it up into Lego-like pieces, where each of the piece could be a memory piece, it could be a logic piece, it could be a processor, for example, a GPU or a CPU, and then you bring that Lego-like puzzle together in a package. That allows us to scale quite a bit. We also have innovations around what we call 3D stacking. Instead of more of a 2D arrangement, can you stack dies together in a 3-dimension? That gives you the ability to also enhance system energy efficiency to a certain extent. And then finally, we are now moving towards optical or photonic interposers. So rather than have neutrons talking to each other? Can we have photons talking that enables us to be a lot more faster and also gain from energy efficiency? So those are some goodness that still exists in the industry, still early days. It will still continue to a certain extent. But if you juxtapose that with the rate at which AI demand is scaling and growing, it just completely dwarfs anything that we are doing today in the semiconductor industry, purely focusing on system scaling or even Moore's law for that matter. So the gray curve that you see here, that's your traditional Moore's law. And then you have the blue curve, that's the rate at which vision models has been growing in the industry. And today, just yesterday, I think our friends at OpenAI talked about GPT-O, which is the latest version. What you see here is GPT-4, that was one version before. That's an enormous model. You have 1 trillion parameters. And in order to train, the amount of compute that you require, that is growing at more than 2 orders of magnitude faster compared to anything else that we have seen in the semiconductor industry. So that's the challenge that we are trying to innovate across. How do we actually solve that challenge as a company? You've got to innovate across the spectrum from system scaling, packaging solutions, innovations in architecture, as well as software. So that's the first, let's say the second challenge after Moore's law. The third biggest challenge is really memory. And I think we are not talking enough in the industry yet about it. The fact is, all of these recent generative AI models, applications like large language models, they're a lot more memory bound. What it means is you spend a lot more time and energy in moving data than actually computing with the data. Moving data across any spectrum, whether that's DRAM or otherwise, it is very much energy expensive. So most of your power consumption goes in moving data. Unfortunately, the memory market hasn't really grown as much compared to the rest of the market. So you'll see there's at least a 50% slow growth in memory market compared to the broader CPU performance. And then, of course, if you compare it to GPU or other types of processors like the ones that we are making as a company, memory growth is much slower. But there is a lot more to come there. So that's really where I am extremely bullish. I think the memory market, things like 3D stacking, optical interconnects, a lot of innovations around next generation HBM. There's a lot of goodness to be had. But that's something that I would advise to watch on, because if there are true innovations coming in the memory market, that's going to enable us to really enhance the efficiency of the processors that we create today, especially for AI computing. The fourth biggest challenge, and that's really the elephant in the room here, that's energy efficiency or sustainability. If you look at the left-hand side here, that's the carbon footprint of a typical GPT language model. And that's just the tip of the iceberg, really. If you compare the CO2 per capita emission for what a typical GPT-4, that's just training a single model, you have orders of magnitude more. Essentially, in this case, you have 3 orders of magnitude more carbon emission, 3,000 homes for 1 year. That's the amount of carbon emission that you are doing during training a single GPT-4 model as compared to per capita. That's unsustainable. So what we as a company have focused on is on the right-hand side, if we break out the entire ecosystem of semiconductors across two simple kind of landscape across performance, because that's what we want to enhance, and across power, that's what we want to minimize. You can break it out into those 4 quadrants. The top left is a joke, a zone of uselessness. Nobody really wants semiconductors that is lower in performance and very high in power. But general consensus is that you want to be in the top right. Usually, that's what you see today in data centers for high-performance computing. So you have these GPU-centric devices that have a lot of performance, but they are also kilowatts, megawatts of power consumptions. We as a company, we have tried to innovate across that bottom right-hand quadrant, which I like to call zone of high efficiency. How do we innovate across that architecture space, software landscape, extract a lot more from, even with the limitations of Moore's law, embrace system scaling aspects, and then focus on the domain of AI. Rather than building very general purpose systems, by focusing on AI, we can really build now power efficient systems, and that's really the focus of us as a company. And that brings me to how do we do it? So I talked about a few of those challenges as much as I can in the limited time. I'll try to walk you through now what are the ways in which we are innovating in order to tackle some of those challenges. The first aspect is concentrating on where the data is. I'll go back to the fact that every time we talk about AI, you think about large data centers. But the reality is 75% of all enterprise data is going to be either generated or created at the edge by 2025. That's what the statistics tell us. That means the majority of the data in the entire world is in your smartphones, is in the cameras, is in the robots, is in the drones, it's in the cars, it's in the satellites, are all on these constrained devices that we call the edge. So if we can bring computation capability directly to the edge, that solves a lot of our memory and latency challenges. And it's also an enormous market by any order of magnitude. If you look at any of these data, it talks about 80 billion plus market. That's probably still kind of undervaluing what that market potential is. That data is already a few years old. In my opinion, the edge market is probably much more larger than what we see here in terms of the data. And that's the first part of the challenge. So rather than looking at purely data center, can we focus on not replacing the data centers, but complementing the data center with energy-efficient solutions, focusing on that edge market? The second aspect is designing systems or processors that are domain-specific. For us, that domain is AI. That's what this simple graph talks about. So if you look at the bottom x-axis, that's your general flexibility. So general-purpose systems like CPUs and GPUs are very flexible. You can do whatever you want with it. Typically, with a CPU, you can make it do anything that you want. It's general purpose. GPU, for that matter, is also general purpose to a lot of extent, but then it works in certain domains much better. So for example, in gaming, in graphics, it does very well. And then we have found that it does well in AI also to a certain extent. But then if you now focus on very narrowly on the domain of AI, build silicon that is completely designed for AI processing and nothing else. So there is no free lunches in this world, right? So you're giving up some general purposeness, but then you're focusing on AI, and that gives you significantly better efficiency. So of course, you've got to innovate across the architectural innovations, but then focusing on that market, we can now extract a lot more performance per watt compared to what traditional architectures can give us. That's what we have concentrated on. Software 2.0, we can probably go into it a little bit later. I'll just mention what that means is software 1.0 is your traditional software, lines of code, of programming. Okay? You sit down, you write your code in your favorite programming language, Python, C++, what have you. Software 2.0 is dramatically different. That's AI. So where the code is actually learned from data. You put a lot of training, training data, large-scale training data, and the model actually learns what the functionality is. It's discovered out of the data itself. Focusing on hardware that was designed to work with such software 2.0, that's, again, going to be able to provide a lot better efficiency as compared to the traditional software 1.0 model. And that's what we are doing as a company. Since we have limited time, I'll just quickly walk you through not every aspect of a solution, but in this chart, you see an integrated platform. I started by talking about the fact that gone are the days where companies were creating purely hardware-centric solutions. So we have focused on this very much integrated platform. On the top left, that's our software platform. The key innovation there was how do we design silicon for a very fragmented market. So unlike the data center, you can have homogeneous data center. You have one data center that is for finance, let's say, one data center being used for a particular industry vertical. But the edge market, it's fragmented. So you have a single solution that is working across various different devices. Our software enables us to marry many of these heterogeneous processors in the market today. And that's kind of the value that you see with the Renaissance being one of the case in points. They have themselves various types of devices. You can have ARM-based systems, RISC-V-based systems, and they can easily mix and marry that with our processors, and the software is taken care by us. On the top right, you have EdgeCortix Sakura. So Sakura, that's kind of talks about our Japan heritage. But that's the first silicon that we brought to market, a 12 nanometer silicon that is purely focused on the edge AI market. A lot more power efficient. So within tens of watts of power consumption, you can now run 10 billion parameter models like Llama, GPT. To a certain extent, GPT is 500 million. So in this case, you're concentrating on models that are designed a lot more for the edge market. It's a lot more energy efficient. On the bottom left, you have architecture, which is very much important. So we are focused on architectures that allows us to go from our current generation monolithic single die solutions all the way to chiplets, a system in chip solutions, system in packet solutions, where you're able to kind of put multiple dies together and the architecture scales. And then finally, we are deploying the solutions with our customers today to various form factors. I'll bring your attention to the one in the center. That's a very small size. It's, the footprint is equivalent to half the size of a typical credit card, but it's designed as a coprocessor. What that means is that you take the device and you can marry that with any existing system and you enhance its behavior. So you have a CPU-based system. You might even have a GPU-based system, for example, let's say even in a satellite, and then you add this coprocessor, small, half the credit card size device, and now you're enhancing its capability for AI processing without changing the power consumption dramatically. That's the power efficiency aspect that we have been talking about. And with that, the markets from an edge perspective is completely open. We are seeing traction across the gamut of different verticals, whether it's smart city. So smart city examples would be multiple cameras being used for both identification, for analytics. Smart retail being another very important industry where we are seeing both from logistics, inventory management, but also from enhancing the user experience or the customer experience inside a retail. A few others that I'll just call out. We mentioned autonomous vehicles. So here we are, deliberately we have the drone image there. So it's not just automobiles in that sense, but it's also the wider landscape. So you have drones, you have UUVs, you have UGVs, and that entire landscape is being innovated across with these kind of devices. And the two more on the bottom that you see there, on the left-hand side, we call this AI RAN. See, we are now seeing that you can marry all this AI processing goodness with the broader radio access network. So we are now, very recently, I believe the 6G logo was made public, and that's where you're seeing a lot more traction of AI being combined with all the goodness of 5G Advanced and 6G, and we can enable that with our processors. And then the bottom right, aerospace and defense. We are very much interested in that market. We have been actively working with various customers in both the defense, aerospace sector, and then low Earth orbit, for example, satellites. So that's another area where we are seeing a lot of traction today, or at least demand for enhancing their capabilities for onboard AI processing rather than doing it in the traditional sense where you would bring all that data down to the Earth from a terrestrial perspective. So finally, there is a lot of, there's a video there, perhaps somebody can just press go. So on the right-hand side, what you see is essentially a video of, if it plays. So if it did play, what you would have seen is that you would have seen text, audio, video all working together. It's essentially a multimodal model, one of the earliest models that DeepMind had brought. Today, we can power those not in a data center, in a large processing, but within a small device, within 10 watts of power consumption. And that's a game changer, in our opinion, in the industry today. So there you go. You see that. And on the left-hand side, if you go back to this performance versus power consumption curve that I talked about, with the Sakura AI accelerator, we are now really focusing, doubling down on the zone of AI, high efficiency, which can marry, it can complement the GPUs. We are not looking to replace that, but GPUs are very good for training purposes. When you have trained those models and you want to deploy them in a very power efficient manner, you can marry that with smaller devices like ours within 10 watts of power consumption, but still run all of those goodness of multimodal AI processing. Very recently, I think just yesterday, GPT launched the GPT-O model. And one of the things that I was talking about, if you have worked with models like Siri, or you've interacted with Siri, Alexa, and others, unfortunately, they are not very, let's say, real. They're not very human-like. So when you're talking to them, it's very difficult to have a conversation where you can interrupt. We all love to interrupt somebody else when they're speaking, right? It's very natural for us. And that's something that we are seeing glimpses of with GPT-O. And that's truly what enhances the user experience of making kind of natural conversations with AI assistants more real. And we are able to enable that with low latency, high speed, directly on devices. So that's really the future that we are excited about. And I'm looking forward to have more conversation with Damian. Thank you for your time. Come back.
Welcome.
Sure.
All right. Everyone can hear us? OK, perfect. Thank you very much, Sakya, for that great presentation.
Sure.
I think this is, I think you were asking, is anyone interested in AI? I think everyone is interested in AI. I think many people in this room, however, would like to know, I think, in some senses, how is the world going to deploy this AI to the edge in a profitable way? And I think in some ways, one of the questions is, where does the value lie? Is it in the data? Is it in, is it in the specific application and domain expertise? Who captures that in your view? And maybe you can use this to highlight some use cases where you've seen where companies or startups or whoever, or large firms perhaps, are tapping into this opportunity at the edge.
Sure. Yeah, that's a great question. I think I touched upon that to a certain extent in the presentation itself. It's a mixture of many of those things. So I think one of the first fundamental aspects is bringing computation directly to the seat of the data itself, as I talked about. And that's easier said than done, given that you are now, any device, let's say even a simple camera that you might have in this room, it's an edge device. It's being exposed to a lot more data than it has ever seen during whatever was the training system that was created. So how do you actually create an algorithm that can learn from the data as much as possible, and then a processing environment that works within that constraints of size, weight, and power? And companies like us are trying to innovate in that space. I think that's going to be the first step. Second step for us is essentially also enhancing the user experience. So more of these edge devices that you'll see prominence is interaction. So people talk about where do you see generative AI playing a role. Think about a simple device. Let's say even you go to your bank, for example, and you have a conversation today in the bank. See, at least in Japan, I think a lot of, we have an aging population, and I think it's a big challenge for us to have human resources all the time. Now, in order for us to have an informed, intelligent conversation, not a passive conversation where you're just searching through data in a database, that's something that today's AI models enable. And where we are innovating is how do we make sure that the hardware can sustain those AI innovations, very, very low latency. You don't go to the data center or the cloud all the time. You preserve the privacy, and you can have a conversation with the person in front of you. An interesting area where we are seeing a lot of traction is the aerospace industry, where traditionally, I'll call that the edge. A plane for me or a jet is an edge, because it's a large, the power consumptions are not as low as a smartphone, but you're constrained. You cannot go to the cloud all the time. We are seeing that a lot of these next generation jets, as well as airlines, are embracing in-flight entertainment to be a lot more user-centric. And today they were constrained by the types of hardware that are a lot more power hungry, like GPUs, for example. So there the demand is, can you run these multimodal text, audio, visual models all combined together within an in-flight entertainment system to enhance the user experience? In cockpit, for example, that has applications both in defense, but also in commercial jets, enhancing the experience of the pilot itself so that they are a lot more informed. You're augmenting them with a lot more richer information source, and that the view of the industry is that should enhance safety. So those are very interesting markets. Satellite is another one I can go on forever.
Well, let's riff on that a little bit. So what you're saying is that, say, one day you have a pilot in the cockpit, maybe you can, instead of talking to a co-pilot or your backseat radar operator, you could have a conversation with an AI, like target those 10 aircraft in front of me. Is that where we're going with this?
Oh, well, on defense, I would rather not comment on that aspect as to, I think we'll probably get into a slippery slope of the imagination. But on the commercial side, I think it's really enhancing the user experience. So as a typical pilot, you are bombarded with a lot more information than what a human mind can handle. That's been the traditional case. Now, in order to narrow down on the problem that you're trying to solve at a given moment in time, that is essentially the AI that we're talking about. Can we narrow down that in a user conversation perspective? And that's the reason you've traditionally always had co-pilots. And the role of the co-pilot is slowly morphing into an AI agent. I'm not saying they're replacing humans necessarily, but really enhancing the ability that you would have. So conversations, finding certain, you have a large knowledge database that you can now easily scan through without having humans to kind of look through that database. That's where we'll see first innovations. Enhancing the user experience in terms of, augmented reality. For example, that's something that is being experimented on, at least for pilots today. We'll see how that gets realized in the commercial sector, but that's kind of enhancing the perception that you would have as human with AI augmentation. Some examples of that already exist. Every one of us who is driving a car today, many of your cars are already has augmented reality. For example, you can see in a heads-up display, the directions. That is, I think, I definitely really like that feature because it makes it a lot more easy to navigate in unknown terrains. You'll see a lot more enhanced behavior there where you can make it a lot more interactive. Today, it's a very passive. It's just giving you that information on your heads-up display, but you cannot interact with it. You cannot tell it that, oh, please find me the closest 7-Eleven, and ensure that there is a parking lot available there that can fit whatever car that I'm driving. Or, give me the safest location in an environment that you feel that's not a very safe environment to drive at nighttime, for example. That kind of interaction, that's the real capabilities that we're talking about, and I think it's going to be there in the next couple of years.
And I think the point you made on power is very important, because if you've ever seen some of these autonomous vehicles, level 4 equipment, you pop the trunk or somewhere, if it's EV, maybe it's in the hood, you suddenly see a whole bevy of electronics, and clearly this, we talk about battery life and essentially the mileage of your car. You can't have half your power consumption basically just going to the electronics. Clearly, power efficiency is so important in these let's just say environments.
Absolutely, yeah. I mean, automotive, I think, so as I said, it's not just in autonomous vehicles, it's not just automotive, but it's really drones and other such devices. They are constrained by size, right? So I think the industry has already enhanced quite a bit. If you take a look at, choose your favorite EV, I'm not going to name a company here, but whatever EV you choose, I think we have already come a long way today in order to reduce the amount of hardware that you would require. But it's truly the marriage of today's more fluid speech, language models, generative AI, and bringing those capabilities to these devices. That's really the game changer that we're talking about. But the industry has really progressed significantly compared to where we were even 5 years ago in terms of the amount of hardware required to get that done in a car.
I was very interested in your comments on certainly the satellite opportunity, and in fact, we discussed this a little bit yesterday. So how do you bring EdgeCortix into space, or is this something that's already coming in onto your roadmap? I'm glad you asked that question. So yeah, I think the space, to a certain extent, is the final frontier. So all the Star Trek fans there. We are extremely bullish about the space industry in general, and we are seeing a lot of demand. We've been working, for us, for example, we've been working actively with NASA. They have a program called NEP, which is essentially their electronic parts and packaging program that they evaluate devices. When we started with our own silicon, to be honest with you, we never really designed it for the space industry. It was a very serendipitous discovery where during the radiation test, we discovered that we have a phenomenon called self-recovery that NASA tells us they had never seen that before in the test they'd done with other types of accelerators like TPUs. And this self-recovery phenomena allows us to essentially have not a single failure case up to quite a high magnitude of radiation tests. And we recently completed the high ion test. That showcases that even devices like ours, commercial devices, are ready to go into space. The reason this is interesting is we are seeing a lot of demand in the satellite industry where both in the government sector as well as the non-government sector, traditional satellites have been a lot more passive. You collect the data and then you send it terrestrial to the Earth to process. Now, in order to reduce the latency and make it a lot more faster in processing, the AI capability needs to be on board the satellite. So in the LEO case, these are going to be really COTS, commercial off-the-shelf solutions. You don't want to spend billions of dollars building just a chip just for the satellite industry. It sounds different from what the traditional space industry has been, but that's really where we are going. So you will see a lot more commercial devices like ours getting into that space. And these satellites will process a lot of the data locally, and then they enhance the communication between satellites. So that's another use case that we are seeing. Geotagging, for example, identify objects from space, and then pass that information to certain other satellites. Could be in the government sector, could be in the non-government sector. And that's something that we are extremely bullish.
You can't have really, even hundreds of watts of power consumption. Typically, you're within a very constrained environment. 10 watts itself is a lot. So that's where efficiency becomes very, very critical.
Right. So if I understand correctly, so instead of sending all the data you're capturing like in just a raw, essentially raw bits from the cameras to Earth, you essentially will analyze the data, tag it beforehand, and send the information that you need.
As much as possible. And you send back the metadata. Right. So essentially, you send back the interesting bits back to your cloud or the data center, while a lot of the processing happens on board itself. Of course, the final frontier really is, to be honest, Mars rovers, as well as the moon rovers that we have sent. When I say we, I mean the industry has sent. They have contained a lot of onboard processing, but they have been with a type of semiconductor called FPGAs. I don't know how many of you have looked into that. They are programmable, but that programmability comes at a cost of power as well. And today, with more ASIC-like solution, domain-specific processors, purely designed for the AI, we can enhance that capability. Imagine enhancing the battery life of a rover even by a few hours. That's enormous. And now we can do that for days. Imagine a satellite, because once you've landed on space, you cannot bring it back again. It's going to be there. It's going to be lasting for a long period of time. So your power consumption, greener solutions becomes critically important. And that's something that we are extremely bullish about. And I think the industry is seeing that I would not call it a niche market, but it's a market where we had not really thought about the applications of AI, and we are seeing very strong tailwinds.
All right. I'm going to shift gears a little bit and just observe, obviously there's a lot of interest with OpenAI's recent announcement, Apple, in the midst of potentially tying up with someone on generative AI models. It seems like a lot of the discussion has been on the level of like very big companies, in the ecosystem giants, as it speaks. But of course, EdgeCortix for now is still a relatively small company, and a lot of the applications you talk about at the edge kind of niche and small, and obviously, in some sense, you're bringing AI to companies or use cases that historically didn't use AI, or at least not AI in this version, and certainly not software 2.0 as we know it. So what is missing in the ecosystem in your view? What needs to develop further, to bring that, what you're offering, and proliferate over, say, the next 3, 5, or 10 years? Obviously, you have a partnership with Renesas. And for those who, I'm sure everyone knows who Renesas is Japan's largest, I would say, microcontroller CPU manufacturer. I mean, it feels like they already have an edge, I guess, in dealing with the edge, because that's kind of their bread and butter. How do you see, the rest of the industry developing? What needs to happen for faster growth at the edge on AI?
Yeah, that's a tough question. Of course, we have been trying to find the answer to that ourselves. Where we think at least the solution lies is not so much on the hardware, but it's really on the software side. And that's the casing point being the Renesas story for us itself. So the fact is the edge market, I think I mentioned that, it's very fragmented. And it's going to be that for a very, very long time. So you'll have diversity of applications. You'll have diversity of form factors. For example, imagine an oil rig. That oil rig is a classic example where you need edge devices to be there, just for monitoring, anomaly detection, predictive maintenance. These are sensors and devices that you require to work all the time in a very, very constrained environment. And then you take it all the way upstream to an aerospace that we were talking about, or a satellite, for example. What helps us permeate across that fragmentation, kind of unify the landscape, is really software. And that's what we have been talking about, software first. So creating a software ecosystem that was designed as a platform, not specifically targeting one type of processor, let's say an x86 or an ARM or a RISC-V. But rather than that, can we create a software that is a lot more heterogeneous friendly, where you can mix and match various types of processors together? In our opinion, that's really the solution. And the example that you see with the Renesas is really there. So, they have been leaders in the market with microcontrollers, microprocessors. But even for them, a challenge has been that across this vast diversity of processors that they are bringing to the market, how do you unify the user experience with a software that can permeate across that, not reinventing the wheel every time? And you've seen that with others, CPU Industries, our friends at Intel or AMD, many of them, I think they are truly embracing the software mindset today, which is, in my opinion, the one of the answers towards really breaking through this diversity of applications and fragmentation. And then on top of that, you add the hardware innovation. So software is the key.
Right. So on that topic, if you look across, probably goes back to something I was asking earlier, where would the value sit? So obviously, you have companies with data. So in specific domains, say robotics, you know the stuff you're trying to do. You know what you're trying to automate. There's obviously one area of value, but they may not have the software capabilities to exploit that value. So that'd be someone who provides that solution to help them, create the domain-specific models, who basically helps them integrate into their, offer a hardware solution or basically integrate into the existing process flow. I think that would be an area of value. How about, in your opinion, is it just making models? I mean, obviously, today everyone's looking at foundational models. Every week there seems to be foundational models. In your opinion, is that an area where value will eventually accrete? Or is basically model making going to commoditize? And yeah.
To be honest, I don't think so. I think that's really what this software aspect that I was talking about is. The industry is not looking for a silver bullet solution that you bring in that suddenly gives you AI capabilities. In fact, robotics is a case in point. HMI, human-machine interactions or human-computer interactions. I think there's a lot of goodness that already exists there. The key question is that any hardware solution that we bring in there, or even software for that matter, can it fit within the existing ecosystem, not trying to replace that completely. So already there's a lot of applications that works extremely well. What we are now looking at is that how do we enhance that capability? A lot of those models, there will be some custom models being developed, but many of the models today already exist in the open source ecosystem. Most companies that are embracing that, I think those are going to be the big winners. Amongst that, there will be certain niche models that will come out where, I think each company will focus on building some of those AI-centric models, enhancing some of those capabilities, either in the robotics domain or, let's say, in the smart city domain. But I highly doubt the scenario where purely model building becomes a capability. Rather, I think what will come into the forefront from at least the machine learning side is the who owns the data, because that's really the key. It's not so much of the model, because you can build models, you can do a lot of things with the open source models itself, but if you own the data, that's really the key. So most companies will focus on that. You'll also see companies come up who are now enhancing the model creation aspect. So not building a type of model. So let's say not creating the next language model necessarily, but the tools necessary to do that.
Right.
So that you have an entire ecosystem of training, going from cloud training to edge deployment, data collection, data annotating. How do you clean the data? We don't talk about that enough, but that's really, I would say, 90% of the work required to deploy an AI model. We talk about architectures a lot more than all that, let's say, the actual shoveling work required. And I think there you'll see a lot more innovation happening.
I suppose that's where I think all of us who are worried about AI taking our jobs will both have to look for it, and looking for ways to actually tag and contribute to the tagging and creation of these models.
I think I can share my mind on that. I don't think that AI is taking our jobs away anytime soon. It's like classic example of thinking about the automotive industry as an example. We had a very different, or industrial revolution for that matter. I think every time new technology comes, we look at it with skepticism. But the fact of the matter is, I think there's going to be a difference in the types of work that we humans do. And AI really, for me, is a augmentation scheme. It's really not a replacement scheme at any way, at least with current technology that we have.
So on that note, maybe if you could just close off by giving us a prediction, say on a 5 or 10 year view, based on what you're seeing, because you clearly can see further than us on many of these topics on AI. What should we be looking out for? Obviously AI is going to change the world. It's going to change the world of work. It's going to change the way we manufacture, the way, perhaps to change our defense industry, suddenly our satellite industry. Is there something that you say, like, okay, you should look out for this thing because it shows that, the world is changing?
I think I always shy away from making predictions because invariably everybody gets the predictions wrong.
I get it wrong all the time, so it's
But
okay.
I think where 5 years is a long time, but I think over the next multiple years in this horizon, this is the continuum between 2 to 5 years, not specifically talking about AI, but the area where you'll see countries embracing this is the prediction would be that most countries now today realize that it's very important to have their own capabilities at the intersection of AI and semiconductors. So just like you have seen models like GPT come out in the US, you'll find that a lot of the countries that we all know, within Asia and Europe as well, you'll find localized models coming out. So very language-specific models, for example, India, Japan for that matter, so Japanese language models, that's going to be a huge innovation area. Second is going to be the ecosystem to run those models. As I talked about, it's very power-hungry. So ecosystem of localized data center is another thing that I truly believe countries will start realizing that they need to build those capabilities themselves. So not just the foundries, so not just the semiconductor facilities, but it's also the entire infrastructure that is a lot more efficient and really tailored and designed for the types of models or ecosystem that they are enhancing. Right. The third prediction I will make is really at the intersection of AI and telecom industry. That's what I called about AI RAN. I think that's really coming. So in the next 5 year or maybe 5 to 6 years horizon, as we steadily move towards 6G, in the industry, we talked about 5G a lot, but truly 5G hasn't really enhanced the capability as much. But I think it's, the waiting moment was AI. That's where I believe that AI RAN, radio access networks, with interactions of AI, will truly enhance the capabilities. Multi-access edge computing MEC will be realized. So yeah, that would be another, I would say, a final prediction that I would make. Definitely in the next 5 years, AI RAN would be realized.
It sounds very exciting, and I think that sounds like it's a big opportunity for EdgeCortix in particular. So, well, thank you very much for your insights, Sakya.
Thank you for having me.
And I really appreciate, I think, you coming all the way to Hong Kong. And I hope you have a good set of meetings today, and all the best, I think, for what looks like to be a very exciting year.
Thank you. We are still a small company. We are growing actively. Always careful of sharing forward-looking statements, but yeah, extremely bullish about the AI industry overall, as well as the semiconductors. Thank you.
Thank you. All right, thank you.